So, now in this lecture, we will start with the earlier topics, that is solution of ordinary differential equation with variable coefficients using the Laplace transform. I have given one example in the last lecture. For easy reference, I think I should give one more example of ordinary differential equation with variable coefficient, so that you can understand properly what is the solution process. Let us take this example. Solve t y double dash plus 1 minus 2 t into y dash minus 2 y equals 0 with y 0 equals 1 and y dash 0 equals 2. So, here you see t y double dash is there, here t into y dash is there. In the earlier example, this was not there. So, let us see whenever both y double dash and y dash consist of the coefficient which is a function of t, what happens over there. So, for this one, initially I am taking Laplace transform of t y double dash plus y 1 minus this thing was there. So, it will be Laplace transform of y dash minus 2 into Laplace transform of t y dash minus 2 into Laplace transform of y, this is equals 0. So, I am getting this one after taking the Laplace transform of t y dash is minus Laplace transform of t y double dash, this is nothing but minus d d s of Laplace transform of y double dash only. So, minus d d s of Laplace transform of y double dash is s square into Laplace transform of y minus s y 0 minus y dash 0 plus Laplace transform of y dash. Laplace transform of y dash is simply s Laplace transform of y minus y 0. Your next term is minus 2 into Laplace transform of t y double dash. This Laplace transform of t into y double dash, this is again minus d d s of this thing. So, it will be plus 2 into d d s of Laplace transform of simply y double dash, that is s into Laplace transform of y minus y naught, plus the last term is minus 2 into Laplace transform of y, this is equals 0. So, please note here Laplace transform of t y double dash, whenever it is there, the value is minus d d s of Laplace transform of y double dash. Laplace transform of y double dash is known to us. Then Laplace transform of y dash, we know it and we put it. Whenever you have Laplace transform of t y double dash, that will be equals to minus d d s of Laplace transform of y dash. So, this has become plus 2 into d d s of Laplace transform of y dash, which we substituted by s into Laplace transform of y minus y naught. Now, here you substitute the values of y naught, y 0, y dash 0 from the given condition. The given condition, according to given condition, y 0 is equals to 1 and y dash 0, this is equals to 2. So, if I substitute these values in the given equation, then I will obtain minus d d s of s square z minus s minus 2 plus s z minus 1. I am not explaining this because this you can find out very easily, plus 2 into d d s of s z minus 1 minus twice z equals 0. So, please note here again, like earlier one, I have assumed that z equals Laplace transform of y. So, I am assuming z equals Laplace transform of y, and by substituting that one, I am just putting Laplace transform of y as z, Laplace transform of y as z in the given equation. So, once I am getting this, so I can break this d d s part and I will obtain this equation minus s square minus twice s into dz ds minus sz, this is equals 0. As I was telling, by assuming z equals Laplace transform of y, what is happening? Your second order ODE is being transformed into one first order ODE, and I have to find the solution of this first order ODE. To find the solution of this I can use the separation of variables. So, dz by z plus it will be simply ds by s minus 2, this is equals 0. So, now dz by I have separated the variables. From here simply I can make it dz by z plus ds by s minus 2 equals 0. So, that integrating both sides I will obtain log z plus log of s minus 2. This is equals some arbitrary constant, say log c. So, that you will obtain log of z into s minus 2, this is equals your log of c. And from here you can write down z equals nothing but z is your Laplace transform of y. So, z equals Laplace transform of y equals simply c by s minus 2. So, you have obtained z equals Laplace transform of y equals c by s minus 2. So, that from here you can write down y equals Laplace inverse of c by s minus 2 directly. So, my next step is from here I am trying to find out this. So, again I am reminding you, whenever you have the parameters, variable parameters as coefficients in the ODE, then the second order ODE is being converted into a first order ODE. I am finding the solution, and then I am finding the solution in this particular format. From here now I can write down your y is equals to c into Laplace inverse of 1 by s minus 2, and I know the function for whose Laplace transform is this. So, that is e power 2 t. Laplace transform of e power 2 t is 1 by s minus 2. Now, I have a condition, that is y 0 equals 1. So, if I use y 0 equals 1, y at t equals 0 is 1, then I will obtain the value of c as 1. So, that I will obtain y equals e power 2 t. So, the solution of my equation is now e power 2 t. Please note this thing. The solution of the given ordinary differential equation is e power 2 t, and I hope that it is clear to you now how we find the solution of ODE with the variable coefficients. So, same thing you can see it over here. I am taking the Laplace transform, then by using Laplace transform of t y double dash equals minus Laplace transform of y double dash, or Laplace transform of t y dash equals minus dds of Laplace transform of y dash. I am getting the next equation. I am substituting the value of y 0, y dash 0 over here. I am getting this. So, that I am deriving by substituting z equals Laplace transform of y. I am converting the second order ODE into a first order ODE, and whose solution I am making the independent variables, and the solution process is this one now, log z equals log of s minus 2 plus c, and log z into s minus 2 equals log c. So, that I can write down z, which is nothing but the Laplace transform of y equals c by s minus 2, and I can write down y equals c into Laplace inverse of 1 by s minus 2, and Laplace inverse of 1 minus s by 2 is nothing but e power 2 t. Here c into e power 2 t. Using the condition y 0 equals 1, I will obtain c equals to 1. So, that the solution of the given differential equation is y equals e power 2 t. Now, this is another one. I am taking another type of example now. Before this, just let me go through this one. That is, we want to study now solution of simultaneous ordinary differential equation. Till now what you have solved only one differential equation. Now, if we have simultaneous ordinary differential equation of two different independent variables, using Laplace transform, how to find out the solution, that we will study in now. So, let us see this one. I want to solve the problem x double dash minus 3x minus 4y equals 0, y double dash plus x plus y equals 0, and the conditions are given as x 0 equals 0, y 0 is 0, y dash 0 is 0, x dash 0 is 0. So, the conditions are given at t equals 0 for x, y, x dash and y dash. To find the solution, of course, I have to go through the similar process, that is, I have to take the Laplace transform on both sides of both the equations. So, if I take the Laplace transform on both sides of the given equations, I will obtain Laplace transform of x double dash minus 3 into Laplace transform of x minus 4 into Laplace transform of y. This is equals to 0. And for the second equation, similarly, Laplace transform of y double dash. So, please note one thing here. Here x and y both are function of t. X double dash or x and y function of t, these are two independent variables whose value I have to find out in terms of t only. So, for the second equation, if I take the Laplace transform on both sides, I will obtain Laplace transform of y double dash plus Laplace transform of x plus Laplace transform of y, this is equals to 0. So, basically instead of one equation, since now you have two simultaneous equations, you are applying Laplace transform on both sides of those two equations together. So, that now for the first equation, you just make it Laplace transform of x double dash, that is s square Laplace transform of x minus x into x 0 minus x dash 0 minus 3 into Laplace transform of x minus 4 into Laplace transform of y, this is equals to 0. For the second equation, similarly, Laplace transform of y double dash can be written as s into Laplace transform of y minus s into y 0 minus y dash 0, plus I have Laplace transform of x plus Laplace transform of y, this is equals to 0 is given. Now, we know the values of x 0, x dash 0, y 0 and y dash 0. Since we know these values, let us substitute it, and by substitution I will obtain the next set of equations, that is s square into Laplace transform of x minus 2 minus 3 into Laplace transform of x minus 4 into Laplace transform of y equals 0. This is first one. Second one will be s square into Laplace transform of y plus L into Laplace transform of x plus L into Laplace transform of plus Laplace transform of y, this is equals 0. So, if I simplify these two equations, I will obtain s square minus 3 into Laplace transform of x plus minus 4 into Laplace transform of y, this is equals 2 will go on this side, and for this one Laplace transform of x plus s square plus 1 into Laplace transform of y, this is equals 0. So, I can tell this is equation 1, this is equation 2, and which has two variables, one is Laplace transform of x, another one is Laplace transform of y. So, by solving these two simultaneous algebraic equations, very easily I can find out what is the Laplace transform of x and what is the Laplace transform of y by solving these two in terms of the function of s. So, by solving equation 1 and 2 for finding the values of Laplace transform of x and Laplace transform of y, we will obtain by solving 1 and 2, you will obtain Laplace transform of x as 2 into s square plus 1 by s square minus 1 whole square, and Laplace transform of y, this you will obtain as minus 2 by s plus 1 whole square into s minus 1 whole square. This I am not explaining because already we have done this thing. So, once I am getting Laplace transform of x in terms of s, Laplace transform of y in terms of s, then I can find out the values of x and y using the inverse Laplace transform. So, Laplace transform of s is this thing 2 by s square plus 1 by s square minus 1, and this I can break it as 1 by s minus 1 whole square plus 1 by s plus 1 whole square, if I can break it like this always. Similarly, Laplace transform of y, this one also I can break it like half into minus 1 by s minus 1 plus 1 by s plus 1 minus 1 by s minus 1 whole square and minus 1 by s plus 1 whole square. I can break it like this. So, once I am obtaining these two things, that is in the denominator I have only one factor whose inverse Laplace transform is known to me, then I can write down x equals Laplace inverse of 1 by s minus 1 whole square plus Laplace inverse of 1 by s plus 1 whole square, and this equals you can write down s minus 1 whole square. So, you can write it as directly I am writing it because e power t into 1 by s square will come using that property, since we are almost going to the end of the Laplace transform. So, directly I can write down this will be t into e power t, and this will be plus 1 is there. So, t into e power minus t. So, you see now I obtained the value of x as t e power t plus t e power minus t. Similarly, your y can be written as half into Laplace inverse of 1 by s plus 1 plus Laplace inverse of 1 by s plus 1, sorry, this will be s minus 1, this is 1 by s minus 1, this will be 1 by s plus 1 minus Laplace inverse of 1 by s minus 1 whole square minus Laplace inverse of 1 by s plus 1 whole square. And I know the Laplace transform of this using the property in terms of e power. I can always write down this will be minus e power t plus e power, this will be minus t whole square is there. So, this will be minus t into e power t minus t into e power minus t. So, once I am getting this, this is my solution I am obtaining. So, like this way, whenever you have two simultaneous equations, using these two simultaneous equations, I am applying the Laplace transform on both of them, and I will get two simultaneous algebraic equations. Once I am getting two algebraic equations, I am solving this and I am finding out the Laplace transform of x and Laplace transform of y. Once I am getting Laplace transform of x and Laplace transform of y using inverse Laplace transform, always I can find out the value of x and the value of y. Just quickly let us see this one. You are taking the Laplace transform on both sides of the given equation. Once I have done this thing, then using the normal process, I am getting the equations 1 and equation 2, which are functions of variables of Laplace transform of x and Laplace transform of y. By solving these two equations, I can tell what is Laplace transform of x and what is Laplace transform of y. And from there, once I got the Laplace transform of x, Laplace transform of y, I can write down Laplace inverse also like this way, using just by breaking it into parts. And from here, I can tell what is my x and what is my y, which already I have written. Just let us do one more example, so that you can understand it again in much better way. Second example is x double dash plus 5 y dash minus x equals t, y double dash minus twice x dash minus 4 y equals minus 2. With x 0 equals x dash 0 equals y 0 equals y dash 0 equals 0. All the values of x, x dash, y dash at t equals 0 is 0. So, please note that x and y are two variables of function of t, and by solving these two ordinary differential equations, we have to find out the solution of this. And for this one, at first let us take the first take Laplace transform on both sides of the given equation. Once I am taking the Laplace transform on both sides of the given equation, I will obtain Laplace transform of x double dash plus 5 into Laplace transform of y dash minus Laplace transform of x, which is equals to Laplace transform of t. And for the second equation, Laplace transform of y double dash minus twice Laplace transform of x dash minus 4 into Laplace transform of y. This is equals Laplace transform of minus 2. So, again by substituting the values of Laplace transform of x double dash, Laplace transform of y dash, Laplace transform of y double dash and Laplace transform of y dash, you will get the next set of equations, that is s square into Laplace transform of x minus s x 0 minus x dash 0. This is for Laplace transform of x double dash plus 5 into s into Laplace transform of y minus y 0. This is for Laplace transform of y dash minus Laplace transform of x. This is equals Laplace transform of t is 1 by s square. And similarly, for this one I will obtain s square Laplace transform of y minus I will obtain s y 0 minus y dash 0. This is for Laplace transform of y double dash minus here it will be 2 into this function is minus 2 is there. So, minus 2 into Laplace transform of x dash. So, s into Laplace transform of x minus x 0, I will obtain minus 4 into Laplace transform of y, and this is equals Laplace transform of minus 2. Laplace transform of 1 is 1 by s. So, that you will get the value as 2 by s. So, you are taking the Laplace transform on both sides of the given equation. Once I am taking the Laplace transform on both sides of the given equation, then I am just breaking it. Now, I will substitute the values of x 0, x dash 0, y 0 and y dash 0, which is provided us all are 0 here. Value of x, y, x dash, y dash at t equals 0 is 0. Substituting these two, again I will obtain from here these two equations, s square into Laplace transform of x plus 5 s into Laplace transform of y minus Laplace transform of x, this is equals 1 by s square, and s square Laplace transform of y minus twice s Laplace transform of x minus 4 into Laplace transform of y equals minus 2 by s square. So, now this again if I little bit simplify, I will obtain s square minus 1 into Laplace transform of x minus 5 s into Laplace transform of y. This is equals 1 by s square and minus twice s Laplace transform of x from here, and plus this will be s square minus 4. So, s square minus 4 into Laplace transform of y, this is equals minus 2 by s. So, this is your equation 1, this is your equation 2. Once I am getting these two equations, if I solve these two algebraic equations, I can find out the values of Laplace transform of x and I can find out the value of Laplace transform of y. So, by solving equation 1 and 2, I will obtain these things. Laplace transform of x, this is equals 11 s square minus 4. I am writing directly, please check it afterwards. S square into s square plus 1 into s square plus 4 and Laplace transform of y, this you will get as minus twice s square plus 4 by s into s square plus 1 into s square plus 4. So, that now Laplace transform of x and Laplace transform of y can be broken. This, if you break it, this will become minus 1 by s square plus 5 by s square plus 1 minus 4 by s square plus 4. Please note that I am not explaining all these things, because these things already has been covered earlier. So, you please check it whether the calculations are correct or not. We have to break it, because as I told you, in the denominator there must be only one term always, so that I can obtain the inverse Laplace transform very easily. And if I break the Laplace transform of y also, you will obtain as 1 by s minus 2 s by s square plus 1 plus s by s square plus 4. So, once I am obtaining this, that is, so now I can tell what would be my x and what would be my y. X will be Laplace inverse of this term and y will be Laplace inverse of this given term. So, in the next step, what I will do, I can write down x equals Laplace inverse of 1 by s square plus 5 into Laplace inverse of 1 by s square plus 1 minus 2 into Laplace inverse of 4 by s square plus 4. And I know all these things. Laplace inverse of 1 by s square, this is minus t, 5 into s square plus 1, this will be sin t minus 2 into, this is a is 2 here. So, a square by s square plus a square. So, it will become, sorry, this is 4 by s square plus 1. So, this will be twice sin into 2 t. And once I am getting this, I got the x in terms of function of t. On the same way, I can write down y equals Laplace inverse of 1 by s minus 2 into Laplace inverse of 2 s by s square plus 1 plus Laplace inverse of s by s square plus 4. So, once I am getting this, Laplace inverse of 1 by s, this is 1 minus 2 into 2 s is there by s square plus 1. So, I can write it as cos of t, sorry, minus, let me cut it, 1 minus 2 cos of t and plus s by s square plus 4. So, cos of 2 t. So, the x value is this minus t into 5 plus 5 sin t minus twice sin t and y equals 1 minus 2 cos t plus cos 2 t. And I hope that now it is clear to you, if you have simultaneous ordinary differential equations using Laplace transform, how to solve the simultaneous linear ordinary differential equations. So, we have covered almost all the things of ODE, how to solve one ODE using Laplace transform with constant coefficients, with variable coefficients. If the initial condition at t equals 0 is not provided, then also how to handle it, that also we have done. So, in the next class, we will see the next part, that is solution of integral equations using Laplace transform.